we are planning to use the Norton theorem for the calculation of voltage V. This voltage V. So here in this case, we are planning to calculate this voltage V across the 2 ohm resistance by using the Norton theorem. Here I already discussed in the last lecture what are the steps required for the calculation based on the Thevenin's theorem or maybe based on the Norton's theorem. Steps are very similar. How are the steps? Here in this particular case, first step is remove the load resistance and short circuit the output terminals. Means we have to remove this, we have to short it, then we have to calculate the current in short circuit and so on. I will start with the step number 1. I will write the first removing the load resistance and redrawing the same circuit we get. Removing load resistance and shorting output terminals we get. So here in this case we are shorting the output terminals by removing the load resistance and we are redrawing the same circuit. If we are redrawing the same circuit, how will be the circuit? The circuit will be something like this. Here it is. This will be the circuit after removing the load resistance and shorting its output terminals. It will be something like this. Here is the current source and we are shorting the output terminals because here is A point maybe, here is B point. In this case we are interested in the calculation of voltage. That's why while calculating its voltage we will first calculate its current. Means this is A point and this is B point. We will short it. This resistance is 1 ohm. It is 4 ohm. This is 3 ohm. Here is the current source which is of the 2 amperes. This is 3 ohm. Is it right? This is the figure. So here in this case we are interested in the calculation of current in this branch. Better way, I will use mesh analysis because I cannot use the direct inspection method because here is the current source. I cannot use the nodal analysis method because here is the short circuit. This branch has nothing, no resistance or no potential. That's why we cannot use the nodal analysis method. That's why I will assume this is loop 1, its current is I1. This is loop 2, its current is I2. And this is loop 3, its current is I3. Use any method. Our aim is the calculation of current in this short circuit. According to this assumed direction of the current, plus minus, this is plus and minus, this is the positive terminal of the battery, this is negative terminal of the battery, this will be the plus minus, this is again plus and minus, this is plus and minus, these are the marking of the terminals. I will use the first point here, applying KVL or whatever we need here in this particular case. So here for first loop, no need to apply the KVL because here is the current source or we are not in a position to apply the KVL. That's why, how will be the equation 1? I will write here, from loop 1 we get. What we get from the loop number 1? From the loop number 1 we will get the equation. How is the equation? This I1 is equal to 2 amperes. This is the equation number 1. This is the equation we will get from the loop number 1. Then if we have this equation, then I will apply the KVL to the loop 2. So here applying KVL to loop 2. If we are applying the KVL, that is Kirchhoff's voltage law, to the loop 2, and if we are traveling from this point into the loop in the upward direction, if we are moving in the clockwise direction, how is the case? We are traveling in this direction, positive to negative, which is minus. Its resistance is 4 and its current will be I2 minus I3 because this branch is common for I2 and I3 or loop 2 and loop 3. This is the case. Then we are traveling from positive to negative, which is minus 3, which is equal to 0. Simplify this equation and get the equation number 2. If we are simplifying this equation, this is minus 4I2 plus it is 4I3, which is minus 3, which is equal to 0. Our equation will be, This is minus 4I2 plus 4I3, which is equal to 3. This is equation number 2. Now, if we have the equation number 2, apply the KVL for loop 3. Here, applying KVL to loop 3. I'm going little fast. If anybody has any doubt, please raise your hand. I will clarify your doubt. For loop 3, I'm starting from this point. We will move in the clockwise direction. We are traveling in this direction, is positive to negative, which is minus. Its resistance is 3. Its current is I3. Then positive to negative minus, its resistance is 4, and its current will be I2 minus. Its current will be I3 minus I2, because we are calculating for loop 3 and we are following the sign conventions of loop 3. This is minus 4 into I3 minus I2. Finally, positive to negative, which is minus, its resistance is 1, its current will be I3 minus I1, which is equal to 0. This is the KVL for loop number 3. Simplify this equation. If we are simplifying this equation, it is minus 3I3, then it is minus 4I3, then plus 4I2, then minus I3, then plus I1, which is equal to 0. If we are separating out the terms, how are the terms? This is I3, this is I3, this is I3. In this case, if we are collecting all these I3s, otherwise I will start with this I1. This is I1, I1 is a single term, is plus I1, this is plus I1. Then it is plus 4I2. Then minus, this is 4 plus 3, 7. 7 and this 1 is the 8. It is minus 8I3, which is equal to, I guess it is 0. And this is the equation number 3. Is it right? We have the 3 equations and 3 unknowns. First, find out the I1 and I2, then we are able to calculate current in the short circuit. Is it right? I will come back to you. Anyone has any doubt? Rishikesh?
Yes, sir.
Whatever the equations we have prepared, अगर वहाँ पे कोई sign conventions में गड़बड़ है plus या minus तो मुझे remind कराना. Right? Anyone has any doubt regarding this particular term? If no, then use the calculator and find out the value of current I1, find out the value of current I2, and finally find out its current, which is I3. Find out 3 currents. But for your sake, I will use this calculator and I will try to find out these values. Is it right? Here I will shift my calculator to the mode. I will come back to the normal mode and I will go to the equation mode. I will select the unknowns 3. What is the first? This is one equation. I1, I2 is 0, I3 is 0. Means how is the multiplier of I1? 1. How is the multiplier of I2? 0. What is for I3? 0. And what is the constant? 2. That is for equation 1. For equation 2, I1 is 0. This is I1 is 0. How much is the I2? Minus 4. How much is the I3? Plus 4. How much is the constant? 3. Then if I am coming to the equation 3, I1 is 1. How much is the I2? Is plus 4. And I3 is a minus 8. And how much is the constant? 0. If we are entering, then x is equal to 1 means I1 is the 2 ampere. Next, I2 is minus 1 ampere. And how much is the I3? This is minus 1 ampere. How much is the I3? Minus 0.25. It is minus 2.25 amperes. All of you check these answers and quickly reply to me. And I am interested in the calculation of ISC or Norton's current, or this is same as IAB. A to B मैं calculate करो because it is the modulus value. A to B calculate करो या B to A calculate करो. We are taking its positive value only. Is it right? So here in this case, A to B हमारा current flow होता है I1, means its value will be I1 minus I2 is the resultant current because I1 is downward, this I2 is upward. This is the value. If I am calculating the same value, which is equal to how much is the I1, which is 2 amperes, minus how much is the I2, minus 1 ampere. This minus up minus plus, if it is 2 plus 1, which is equal to 3 amperes, is the Norton's current. Means current flowing through this particular circuit is minus 3 amperes. It's indirectly the value of the Norton's current is minus 3 amperes. I will check these answers with someone. If anybody has ready answer with you, then please raise your hand. I will unmute you and we will check these values. Just I'm waiting for your reply. If you are ready with the answer, please raise your hand. Anyone? Yes, I will come back to you. Saurabh.
Hello.
Are you ready with the answers?
Yes, sir. Correct.
Correct. Ruchira. Yes. Unmute yourself.
Correct, sir. Answer.
Rishikesh.
Sir, correct.
Yeah. Now here, if we know its value of the current, which is nothing but the Norton's current, then we will find out its resistance, which is the Norton's resistance. Now here, how is the procedure for the calculation of the Norton's resistance? For the calculation of the Norton's resistance, we will remove this load resistance and we will remove the sources by internal resistance and we will find out the resistance between the terminals A and B. I will write the same. For the calculation of Norton's resistance, we will remove load resistance and sources are replaced by respective internal resistances. How will be the figure? Its figure will be something like this. Here is A point. This is our B point. This resistance will be as it is. This resistance will be again as it is. And here is the top resistance, which is also we are keeping the same, that is as it is. This is current source. It should be replaced by open circuit. And this is the voltage source, 3 volt. It should be replaced by the short circuit. This our figure will be something like this. This is A point. This is B point. Here it is 1 ohm. This is 4 ohm. And this resistance is 3 ohm. The circuit will be something like this. First, simplify this circuit. Take these terminals outside and try to find out its values. Or I will come back to you. Can anyone able to answer which resistances are in the series combination or which are in the parallel combination for the reduction of this network? Anyone has any clue? If yes, please raise your hand. What are the series and parallel combinations? Yes. Anyone? No? It is not that much difficult. You have to be smart, my dear students. Yes, Shailesh.
Yes, sir.
Do you have any clue? What is the series or parallel combination? Okay. Saurabh.
3 and 1 series में.
Fine. Then why you are not answering? You know the answers. You need to be a little interactive because we are in the online mode. Yes. You have to be interactive. Because I must know what is your perspective. Avinash. Yeah. Here, what I will do, I will redraw this figure. I will assume this is the figure which is made up of the elastic. I will pick this point A and I will pick this another point B and I will stretch the figure. If I am stretching the figure, the A will be here, something like this. This is 1 ohm. If I am taking this A here and I am stretching this figure. In that case, how will be the figure figure will be something like this. Here will be the 1 ohm, here will be the 3 ohm resistance, and here will be the 4 ohm resistance, something like this. Here this is the common point, this common point, because I am picking these 2 points, I am stretching the figure, and here this point will be the B point. Are you getting me? Here is the 1 ohm, this will be the 3 ohm, and this resistance will be the 4 ohm. Now take it out this point little away. This is the point A, and this point will be the B point. Now this figure is very simple, and we are in a position to find out its values. How is the case? This 3 and 1 is in series, means 4 is a parallel with the 4. This next figure will be something like this. This is 4 ohm, and this resistance is again 4 ohm. This is the B point. This is 4 ohm. Here it is 4 ohm, and this point is the A point. And finally, if we are finding its parallel combinations in this particular case, this Rn is equal to 4 into 4 divided by, it is 4 plus 4, which is the 2 ohm, is the value of Rn, which is nothing but the Norton's resistance in this particular case. This is right. You have to be more interactive, because that's why I'm planning for the next TAE, that is to be the PowerPoint presentation. Means you need to be talkative. Is it right? Now here in this case we know the IN and we know the RN. Now I will write the same. If we know IN and RN, then complicated network is replaced by what? Norton's equivalent network. How is the Norton's equivalent network? It will be something like this. And reconnect the load resistance which is removed in the first step. This is the Norton's equivalent network. Here is the load resistance which we have removed in the step number 1. Rn, which is 2 ohm. And how much is the IN? We have calculated this value of the IN, which is 3 amperes. This IN is 3 amperes. And how much is the load resistance which we have removed? Load resistance is 2 ohm, and we are interested in the calculation of the voltage across that. First we will calculate its current, and then we will calculate its voltage. It is 2 ohm. This is terminal A and this is terminal B. Now use the Norton's theorem. This is the load resistance. Its current is IL. What is the formula for IL? No need to mug up the formula. You can use the current division rule. If total current is known, what is the formula? Total current, which is 3, into resistance of the opposite branch, which is 2, divided by resistance of both branches, that is 2 plus 2. This is right. Because in this branch current is known, in this branch we are interested in the calculation. This will be the opposite branch divided by resistance of both branches. And how much is this value? I guess it is 1.5 amperes, because both resistances are same. This 3 amperes, half will be in this branch and half will be in another branch. This is the IL. If we know the IL, we are interested in the calculation of the voltage across that resistance. V is equal to 2 into its current, which is 1.5, which is equal to how much? 3 volt is the value of the voltage across that resistance using this theorem, which is nothing but the Norton's theorem.